how he gets connected to the same IP address. I mean, how is he getting service with the same IP address? Imagine that I have a guy uh, who is using laptop and he's connected over a Wi-Fi network with the help of one access point. Maybe here it is. Let me draw somewhere here. Okay. Here is my first AP and here is my second AP. My first AP is giving coverage maybe around 100-meter long, and second AP is there, which is providing coverage like mm, maybe another 100-meter like this. Now, if a guy who is standing almost like here in this location, when he moves all the way from here to slowly moves back here, now when he travels from one AP service area to other service area, this area in which my AP provides service, right, normally termed as BSS ID. I'm sorry, BSS, Basic Service Set, and the Wi-Fi name to which I am connected to is called BSS ID. So of course, in your LAN environment, all my APs will be providing same uh, same Wi-Fi name. Imagine that his Wi-Fi name is student here. Of course, he'll be providing Wi-Fi, and that name also will be student only. But one point which you have to remember is that the wireless MAC address will still be changing. The wireless MAC address to which the guy who is standing here was connected to will be something like maybe ending with 0A. Normal wireless MAC address looks like normal MAC address, and he is connected to the student SSID. When he moves all the way to here, he gets connected to a different wireless MAC address, maybe 0B ending with, but he still get connected to the student Wi-Fi name only. This is one scenario when my access points are under same controller's control. Maybe I have same controller who is controlling the access points. Now we will discuss about when this guy is moving from one controller to other controller itself. Let's talk about this one by one. So overview, client knows how to roam between one AP to another AP. Roaming should not disturb the client service. Yes, and you will learn how a client roams from one AP to another AP and one controller to another controller. If I'm talking about I'm saying one AP to another AP, it means he is under same controller, but he's just that he's traveling from one AP of the controller to other AP. If I'm saying one controller to another controller, it means he is traveling from one controller's AP to other controller AP itself. Maybe client was here in this place and he is traveling from here to some other place which is under the control of some other controller. In that case, what will happen? So you can term this as intra controller roaming. This can be termed as inter controller roaming. That is intra controller roaming. This one is termed as inter controller roaming. Now we'll also study how do we track a client who is connected to the AP. I mean, we can track how many clients are connected, and we can also track a geographical location of a single client. We'll talk about this in brief, why we need to find out where the client is located in my Wi-Fi network. So let's talk about client roaming overview. So let's think as if my clients are associated with a single controller and they are just moving or roaming between two autonomous APs or two lightweight APs. See what happens, the client, nothing but my laptop, will keep an eye on the quality of network when it moves from one end to other end. So imagine that I have two area like this is my first AP signaling area and this is my second AP signal area, and I am standing somewhere here with my laptop. This is my AP number 1, this is my AP number 2. Now my client, nothing but my laptop, will keep an eye on or keep on monitoring the Wi-Fi signal quality strength. So as you go, he goes away from the service set or BSS area of AP1. The signals start getting degrading, like they get degraded. So immediately, what happened? Your client, I mean your laptop, will start looking for some other AP with the same settings, nothing but your BSS ID, same Wi-Fi name, and the process is very fast when he moves from this location to this location. It happens in frequency of second that your client will never feel a disrupt in this network. Okay. So when a client actually moves from one area to other area, my client need to send something called probe request to discover the candidate AP. Candidate AP nothing but the number of APs which are available in a whole. We can say it as or term it as candidate AP. So client can send something called association request if the client is newly joining to that particular AP. What if I'm just roaming here and there in between these two BSS area? I'm roaming between here and here. So in that case, when I go there and come back to my normal area, so in that case, I can simply send a reassociation request frames where I want to reassociate myself to my old AP. So my laptop will keep an eye or store a cache of all the APs I'm traveling and all the MAC address information to which I'm connected to. And as a user, we will not notice that. So let's see the same thing. So before and after association, uh, why is not moving? So if AP1 has any leftover wireless frames destined for the client after roaming, then this guy will forward that information over my wired network. See here we are talking about autonomous AP. We are not talking about lightweight AP. Your autonomous AP, which means they are self-contained and they normally we have to manually configure them by getting into this device. If you have a controller, in that case, this switch will be replaced by the controller, but still the function is same. I mean, the way data traffic will move in case my client is moving from here to here. Imagine that I have a client one. He is in this SSID. He is moving from here to here. So when he moves, imagine that my APs was sending some information to him, right? But suddenly my client moves from here to here. My APs, the data which I already have for my client, may be lost, right? So that loss will not happen. So my AP is smart enough to send the information to my switch and then send it back to another AP to which my AP is reconnected to. And for this, my client might have already informed my AP1 that I am going to go away from you to another AP, and he might have informed this AP's information, like AP's MAC address information, so that he can transfer that within my LAN segment. So in this scenario where I have a layer 3 switch, you can see my IP address have not changed. So client no need to change its own IP address when it's traveling within the same controller network or within the same switch network. So the things will change when you are actually traveling from one subnet into another subnet area maybe. So initially my AP1 has information about association. He say the client one is associated with me, and AP2 as you can see it's nil. Now once this guy moves from here to here, my association will go blank. It's not like that I will maintain information about him. My association will go blank, but my AP2 association will show that client one is here. Now, as my AP1 knows already where my client one is going to move because of weaker signal, I just send out the leftover packets over the layer 3 switch or layer 2 switch. This happens when my AP is moving from one network to the same network on other AP. So it's obvious that we will not have simply like two APs. So client can move from one AP to other AP dynamically when he is working from one building floor to other floor. He might be end up connecting to 10 or 15 APs, but without his notice. So let's talk about first intra-controller roaming. Then we'll talk about inter-controller. Guys, intra or inter will come. Let's talk about intra-controller roaming, which means I'm going to make use of lightweight APs, and I have maybe I have two APs inside one controller roof, and client want to move from one AP to other AP within that controller, and that is called intra-controller roaming. So here my AP will not worry much about the clients. My controller will take care of entire roaming process. The client roaming here will be very faster, like it will be less than 10 millisecond to say, go from one controller to other controller, because the controller already have my, imagine that this is a controller and this is my lightweight AP, and my controller already has the AP and associated client information, maybe client one here, and it says AP2, as of now it is 0. So when it moves from here to here, immediately my association table will go blank for AP1. For AP2, it writes the client information. So as my controller already know about the client, it's more efficient than normal inter-controller roaming. So apart from just roaming, there are two more specific function which is carried out by the client. First one is DHCP lease will be renewed. Why? Because maybe my client got the IP address from one of the AP, maybe AP1. And when it moves from one AP to other AP, it try to refresh the IP address what he has, instead of again getting into some issues, like maybe my IP address got leased out. Will this lease time got expired? I need to again get the IP address. Instead of doing that, I'll just renew my IP address whenever I go into a new AP control. Client authentication can be done as a fresh. It will not done actually, because client authentication is done by the controller, right? And it uses 802.1x method, nothing but your AAA method, authentication, authorization, and accounting, using the Radius server and Radius servers. Yeah, using the Radius servers. So as my controller already performed the authentication, again he will not perform the client authentication, like just avoids it. Now, what are different types of authentication? What I can use on my Wi-Fi network? There are majorly three types of authentication that is possible for a single client who is roaming here and there. First one is CCKM, expands to Cisco Centralized Key Management, where I'm going to have a database with client password information, like client keys. So on behalf of AP, I have my centralized management server. It can be a server which stores the username and password. And then when a client tries to access my AP, or when he want to get into my Wi-Fi network, I authenticate it. So now what is key caching? Now each client maintains a list of keys used by the prior AP association when it roams, and destination when it roams. And when it roams from one AP to other AP, the destination AP must present in this list. Why am I doing key caching? Very simple. See the key which I received, right? So every time I authenticate my password, I'll get a reply from the server saying that this is the key value. Maybe that's like 09EB4321, something a key. And this key must be unique. It's kind of a VPN key. If you have used a soft key, maybe. Like I can show you one key here. In my laptop also I have one. Normally to connect to a VPN network, I use it next to each other. If a lot of people are interested as standing here and watching this shampoo bottle more than like 3 minutes, and you see less head counts here, or less Wi-Fi signals or users here, you can simply think that more people are worried about this brand rather than this brand. These things you can do with the help of WLC device location. So to be precise, we have to compare multiple AP results. Of course, you will have multiple APs, right? So if you connect to one Wi-Fi signals, you can also activate other APs to keep an eye on the user. In other ways, if you are having or running, if you're having a hospital and you want to make sure to give full Wi-Fi network to your hospital network, So in that case also you can figure it out, like where is my more users sitting, where I have less users. Based on that count, I can supply the Wi-Fi signal. So you can install some applications, something called real-time location services, RTLS, which you can give you the service of actually where the user is located. And also you can perform these things on Cisco Prime infrastructure or DNA centers softwares, and you can integrate that with the servers like Cisco MSC. I haven't worked on this thing at all. Mobility Service Engines MSC and CMX. These things comes under CCNP wireless. Just introduction for us. Okay, so that's it. So if you have any question in this, you can ask me now.
No, Vishnu.
Okay, then we'll take a break. Come back by when? 8:36, 8:46. Come back by 8:47 then. Okay.
Okay.
Okay. Thank you.